Let us now get started with aggregation exercises, and the first problem, count the number of facilities. So I can go to the facilities table, and then when I want to count the number of rows in a table, and here every row is a facility, I can use the count star aggregation, and we get the count of facilities. So what we see here is a global aggregation. And when you run an aggregation without having done any grouping, it runs on the whole table. Therefore, it will take all the rows of this table, no matter how many, compress them into one number, which is determined by the aggregation function. In this case, we have a count, and it returns a total of 9 rows. So in our map, aggregation happens right here. So we sourced the table, we filtered it if needed, and then we might do a grouping, which we didn't do in this case. But whether we do it or not, aggregations happen here. And if grouping didn't happen, the aggregations at the level of the whole table. Count the number of expensive facilities. This is similar to the previous exercise. We can go to the facilities table. But here we can add a filtering because we're only interested in facilities that have guest cost greater than or equal to 10. And now once again, I can get my aggregation count star to count the number of rows of this resulting table. Looking again at our map, why does this work? Because with the from, we're sourcing the table, and immediately after the where runs and it drops unneeded rows. And then we can decide whether to group by or not. And in this case, we're not doing it. But then the aggregations run. So by the time the aggregations run, I've already dropped the rows in the where. And this is why in this case, after dropping some rows, the aggregation only sees 6 rows, which is what we want. Count the number of recommendations each member makes. So in the members table, we have a field which is recommended by, and here is the ID of the member who recommended the member that this row is about. So now we want to get all these recommended by values and count how many times they appear. So I can go to my members table. And what I need to do here is to group by recommended by. So what this will do is that it will take all the unique values of this column recommended by, and then it will allow me to do an aggregation on all of the rows in which those values occur. So now I can go here to select and call this column again. And if I run this query, I get all the unique values of recommended by without any repetitions. And now I can run an aggregation like count star. What this will do is that for recommended by value 11, it will run this aggregation on all the rows in which recommended by is 11. And the aggregation in this case is count star, which means that it will return the number of rows in which 11 appears, which in the result happens to be 1. And so on for all the values. What I also want to do is to order by recommended by to match the expected results. Now what we get here is almost correct. We see all the unique values of this column, and we see the number of times that it appears in our data. But there's one discrepancy, which is this last row over here. So in this last row, you cannot see anything, which means that it's a null value. So it's a value that represents absence of data. And why does this occur? If you look at the original recommended by column, there is a bunch of null values in this column because there's a bunch of members that have null in recommended by. So maybe we don't know who recommended them, or maybe they weren't recommended, they just applied independently. When you group by, you take all the unique values of the recommended by column, and that includes the null value. the null value defines a group of its own. And the count works as expected because we can see that there are 9 members for whom we don't have the recommended by value. But the solution does not want to see this because we only want to see the number of recommendations each member has made. So we actually need to drop this row. Therefore, how can I drop this row? Well, it's as simple as going to after the from and putting a simple filter and saying recommended by is not null. And this will drop all of the rows in which that value is null, therefore it won't appear in the grouping, and now our results are correct. Remember, when you're checking whether a value is null or not, you need to use the is null or is not null. You cannot actually do equal or not equal, because null is not an actual value. It's just a notation for the absence of a value. So you cannot say that something is equal or not equal to null. You have to say that it is not null. Let's list the total slots booked per facility. Now, first question, where is the information that I need? The number of slots booked is in the CD bookings, and there I also have the facility ID, so I can work with that table. And now, how can I get the total slots for each facility? I can group by facility ID, and then I can select that facility ID. And within each unique facility ID, what type of aggregation might I want to do? In every booking, we have a certain number of slots, right? And so we want to find all the bookings for a certain facility ID and then sum all the slots that are being booked. So I can write sum of slots over here. And then I want to name this column total slots, looking at the expected results, but this will actually not work because it's two separate words. So I actually need to use quotes for this. And remember, I have to use double quotes because it's a column name. So it's always double quotes for the column name and single quotes for pieces of text. And finally, I need to order by facility ID. And I get the results. So for facility ID 0, we looked at all the rows where facility ID was 0, and we squished all of this to a single value, which is the unique facility ID. And then we looked at all the slots that were occurring in these rows, and then we compressed them, we squished them to a single value as well, using the sum aggregation, so summing them all up, and then we get the sum of the total slots. List the total slots booked per facility in a given month. So this is similar to the previous problem, except that we are now isolating a specific time period. And so let us think about how we can select bookings that happened in the month of September 2012. Now we can go to the bookings table and select the start time column. And to help our exercise, I will order by start time descending, and I will limit our results to 20. And you can see here that start time is a timestamp column, and it goes down to the second because we have year, month, day, hour, minutes, second. So how can we check whether any of these dates corresponds to September 2012? We could add a logical check here. We could say that start time needs to be greater than or equal to 2012 September 1st, and it needs to be strictly smaller than 2012 October 1st. And this will actually work. As an alternative, there is a nice function that we could use which is the following: date trunc month start time. Let's see what that looks like. So what do you think this function does? Like the name suggests, it truncates the date to a specific granularity that we choose here. And so all of the months are reduced to the very first moment of the month in which they occur. So it is sort of cutting that date and removing some information and reducing the granularity. I could, of course, have other values here, such as day, and then every timestamp here would be reduced to its day. But I actually want to use month. And now that I have this, I can set an equality, and I can say that I want this to be equal to September 2012. And this will actually work, and I also think it's nicer than the range that we showed before. Now I've taken the code for the previous exercise and copied it here because it's actually pretty similar, except that now after we get bookings, we need to insert a filter to isolate our time range. And actually we can use this logical condition directly. I'll delete all the rest. And now what I need to do is to change the ordering, and I actually need to order by the total slots here. And I get my result. To summarize, I get the bookings table, and then I take the start time timestamp and I truncate it because I'm only interested in the month of that time, and then I make sure that the month is the one I actually need. And then I'm grouping by facility ID, and then I'm getting the facility ID, and within each of those groups I'm summing all the slots, and finally I'm ordering by this column. List the total slots booked per facility per month in the year 2012. So again, our data is in bookings, and now we want to see how can we isolate the time period of the year 2012 for this table. Now once again, I am looking at the start time column from bookings to see how we can extract the year. So in the previous exercise, we saw the date trunc function, and we could apply it here as well. So we could say date trunc start time, year from start time, right? Because we will want to see it at the year resolution. And then we would get something like this. And then we could check that this is equal to 2012 0101. And this would actually work. But there's actually a better way to do it. What we could do here is that we could say extract year from start time. And when we look at here, we got an integer that actually represents the year. And it will be easy now to just say equal to 2012 and make that test. So if we look at what happened here, extract is a different function than datetime because extract is getting the year and outputting it as an integer, whereas datetime is still outputting a timestamp or a date just with lower granularity. So you have to use one or another according to your needs. Now to proceed with our query, we can get CD bookings and add a filter here and insert this expression in the filter, and we want the year to be 2012. So this will take care of isolating our desired time period. Next, we want to check the total slots within groups defined by facility ID and month. So we want the total for each facility for each month, as you can see here in the respected results, such that we can say that for facility ID 0 in the month of July in the year 2012, we booked 270 slots. So let's see how we can do that. This basically means that we have to group by multiple values, right? And facility ID is easy, we have it. However, we do not have the month. So how can we extract the month from the start time over here? Well, we can use the extract function, right? Which we just saw. So if we write it like this and we put month here, this function will look at the month and then will output the month as an actual integer. And the thing is that I can group by the names of columns, but I can also group by transformations on columns. It works just as well. SQL will compute this expression over here, and then it will get a value, and then it will group by that value. Now, when it comes to getting the columns, what I usually do is that when I group by, I want to see the columns in which I grouped. So I just copy what I had here and I add it to my query. And then what aggregation do I want to do within the groups defined by these two columns? I have seen it in the previous exercise. I want to sum over the slots and get the total slots. I also want to take this column over here and rename it as month. And now I have to order by ID and month. And we get the data that we needed. So what did we learn with this exercise? We learned to use the extract function to get a number out of a date, and we use that. We have used grouping by multiple columns, which simply defines a group as the combination of the unique values of two or more columns. That's what multiple grouping does. We have also seen that not only you can group by providing a column name, but you can also group by a logical operation. And you should then reference that same operation in the select statement so that you can get the value that was obtained. Find the count of members who have made at least one booking. So where is the data that we need? It's in the bookings table. And for every booking, we have the ID of the member who has made the booking. So I can select this column, and clearly I can run a count on this column, and the count will return the number of non-null values. However, this count, as you can see, is quite inflated. What's happening here is that a single member can make any number of bookings, and now we're basically counting all the bookings in here. But if I put distinct in here, then I'm only going to count the unique values of memID in my bookings table. And this gives me the total number of members who have made at least one booking. So count will get you the count of non-null values, and count distinct will get you the count of unique non-null values. List the facilities with more than 1,000 slots booked. So what do we need to do here? We need to look at each facility and how many slots they each booked. So where is the data for this? As you can see, again, the data is in the bookings table. Now I don't need to do any filter, so I don't need the where statement, but I need to count the total slots within each facility. So I need a group by. And I can group by the facility ID. And once I do that, I can select the facility ID. And to get the total slots, I can simply do sum of slots and I can call this total slots. It's double quotes for a column name. Now I need to add the filter. I want to keep those that have sum of slots bigger than 1000, and I cannot do it in a where statement, right? So if I were to write this in a where statement, I would get that aggregate functions are not allowed in where. And if I look at my map, we have been through this again. The where runs first, right after we source the data, whereas aggregations happen later. So the where cannot be aware of any aggregations that I've done. For this purpose, we actually have the having component. So the having component works just like where. It's a filter. It drops rows based on logical conditions. The difference is that having runs after the aggregations and it works on the aggregations. So I get the data, do my first filtering, then do the grouping, compute an aggregation, and then I can filter it again based on the result of the aggregation. So I can now go to my query and take this and put having instead of where and place it after the group by, and we get our result. And all we need to do is to order by facility ID. And we get our result. Find the total revenue of each facility. So we want a list of facilities by name along with their total revenue. First question, as always, where is my data? So if I want facilities name, it's in the facilities table. But to calculate the revenue, I need to know about the bookings. So I'll actually need to join on both of these tables. So I will write from cd bookings book join cd facilities facts on facility ID. Next, I will want the total revenue of the facilities, but I don't even have the revenue yet. So my first priority should be to compute the revenue. Let us first select the facility name, and here I will now need to add the revenue. So to do that, I will need to have something like cost times slots, and that determines the revenue of each booking. However, I don't have a single value for cost. I have two values, member cost and guest cost. And as you remember from previous exercises, I need to choose every time which of them to apply. And the way that I can choose is by looking at the member ID. And if it's 0, then I need to use the guest cost. Otherwise, I need to use the member cost. So what can we use now in order to choose between these two variants for each booking? We can use the case statement for this. So I will say case and then immediately close it with end. And I will say when book memid equals 0, then fax guest cost. I always need to reference the parent table after a join to avoid confusion. Else fax member cost. So this will allow me to get the cost dynamically. It allows me to choose between two columns. And I can multiply this by slots and get the revenue. Now, if I run this, I get this result, which is the name of the facility and the revenue. But I need to ask myself, at what level am I working here? In other words, what does each row represent? Well, I haven't grouped yet, so each row here represents a single booking. Having joined bookings and facilities and not having grouped anything, we are still at the level of this table where every row represents a single booking. So to find the total revenue for each facility, I now need to do an aggregation. I need to group by facility name and then sum all the revenue. I can actually do this within the same query by saying group by facility name. And if I run this, I will now get an error. Can you figure out why I'm getting this error now? So I have grouped by facility name, and then I'm selecting by facility name, and that works well because now this column has been squished, has been compressed to show only the unique names for each facility. However, I am then adding another column, which is revenue, which I have not compressed in any way. Therefore, this column has a different number of rows than this column. And the general rule of grouping is that after I group by one or more columns, I can select by the columns that are in the grouping and aggregations, right? So nothing else is allowed. So fax name is good because it's in the grouping. Revenue is not good because it's not in the grouping and it's not an aggregation. And to solve this, I can simply turn it into an aggregation by doing sum over here. And when I run this, this actually works. And now all I need to do is to sort by revenue. So if I say order by revenue, I will get the result that I need. So there's a few things going on here, but I can understand it by looking at my map. Now, what I'm doing is that I'm first sourcing the data, and I'm actually joining two tables in order to create a new table where my data is. Then I'm grouping by a column, which is the facility name. So this compresses the column to all the unique facility name. And next, I run the aggregation, right? So the aggregation can be a sum over an existing column. But as we saw in the mental models course, the aggregation can also be a sum over a calculation. I can actually run logic in there. It's very flexible. So if I had a revenue column here, I would just say sum revenue as revenue, and it would be simpler. But I need to put some logic in there. And this logic involves choosing whether to get guest cost or member cost. But I'm perfectly able to put that logic inside the sum. And so SQL will first evaluate this logic for each row, and then it will sum up all the results and it will give me revenue. Finally, after computing that aggregation, I select the columns that I need, and then I do an order by at the end. Find facilities with a total revenue of less than 1,000. So the question is pretty clear, but wait a second. We calculated the total revenue by facility in the previous exercise. So we can probably just adapt that code. Here's the code from the previous exercise, so check that out if you want to know how I wrote this. And if I run this code, I do indeed get the total revenue for each facility. And now I just need to keep those with a revenue less than 1,000. So how can I do that? It's a filter, right? I need to filter on this revenue column. I cannot use a where filter because this revenue is an aggregation and it was computed after the group by after the where. So the where wouldn't be aware of that column. But as we have seen, there is a keyword. There is a statement called having, which does the same job as where. It filters based on logical conditions. However, it works on aggregations. So I could say having revenue smaller than 1,000. Unfortunately, this doesn't work. Can you figure out why this doesn't work? In our query, we do a grouping and then we compute an aggregation. and then we give it a label. And then we try to run a having filter on this label. If you look now at our map for the logical order of SQL operations, this is where the group by happens. This is where we compute our aggregation. And this is where having runs. And now having is trying to use the alias that comes at this step. But according to our rules, having does not know of the alias that's assigned at this step because it hasn't happened yet. Now, as the discussion for this exercise says, there are in fact database systems that try to make your life easier by allowing you to use labels in having, but that's not the case with Postgres. So we need a slightly different solution here. Note that if I repeated all of my logic in here, instead of using the label, it would work. So if I do this, I will get my result. I just need to order by revenue. And you see that I get the correct result. Why does it work when I put the whole logic in there instead of using the label? Once again, the logic happens here. And so the having is aware of this logic having happened. But the having is just not aware of the alias. However, I do not recommend repeating logic like this in your queries because it increases the chances of errors and it also makes them less elegant, less readable. So the simpler solution we can do here is to take this original query and put it in round brackets and then create a virtual table using a common table expression here and call this, all of this, T1. And then we can treat T1 like any other table. So I can say from T1 select everything where revenue is smaller than 1000 and then order by revenue. Remove all this and we get the correct answer. To summarize, you can use having to filter on the result of aggregations. Unfortunately, in Postgres, you cannot use the labels that you assign to aggregations in having. So if it's a really small aggregation, like if it's select some revenue and then all of the rest, then it's fine to say some revenue smaller than 1000. There's a small repetition, but it's not an issue. However, if your aggregation is more complex, as in this case, you don't really want to repeat it, and then you're forced to add an extra step to your query, which you can do with a common table expression. Output the facility ID that has the highest number of slots booked. So, first of all, we need to get the number of slots booked by facility. And we've actually done it before, but let's do it again. Where is our data? The data is in the bookings table. And we don't need to filter this table, but we do need to group by the facility ID. And then once we do this, we can select the facility ID. This will isolate all the unique values of this column. And within each unique value, we can sum the number of slots and call these total slots. And if we do this, we get the total slots for each facility. Now to get the top one, the quickest solution really would be to order by total slots and then limit the result to 1. However, this would give me the one with the smallest number of slots because order is ascending by default, so I need to turn this into descending, and here I would get my solution. But given that this is a simple solution and it solved our exercise, can you imagine a situation in which this query would not achieve what we wanted it to? Let us say that there were multiple facilities that had the top number of total slots. So the top number of slots in our dataset is 1404. That's all good. But let's say that there were two facilities that had this top number, and we wanted to see both of them for our business purposes. What would happen here is that limit 1, so everything else would work correctly and the ordering would work correctly, but inevitably in the ordering, one of them would get the first spot and the other would get the second spot. And limit 1 is always cutting the output to a single row. Therefore, in this query, we would only ever see one facility ID, even if there were more that had the same number of top slots. So how can we solve this? Clearly, instead of combining order by and limit, we need to figure out a filter. We need to filter our table such that only the facilities with the top number of slots are returned. But we cannot really get the maximum of some slots in this query. Because if I tried to do having some slots equals maximum of some slots, I would be told that aggregate function calls cannot be nested. And if I go back to my map, I can see that having can only run after all the aggregations have completed. But what we're trying to do here is to add a new aggregation inside having, and that basically doesn't work. So the simplest solution here is to just wrap all of this into a common table expression and then get this table that we've just defined and then select star where the total slots is equal to the maximum number of slots, which we know to be 1404. However, we cannot hard code the maximum number of slots because for one, we might not know what it is, and second, it will change with time, so this won't work when the data changes. So what's the alternative to hard coding this? We actually need some logic here to get the maximum value, and we can put that logic inside the subquery. And the subquery will go back to my table T1, and it will actually find the maximum of total slots from T1. So first this query will run, it will get the maximum, and then the filter will check for that maximum. And then I will get the required result. And this won't break if there are many facilities that share the same top spot. Because we're using a filter, all of them will be returned. So this is a perfectly good solution. For your information, you can also solve this with a window function, and which is a sort of row level aggregation that doesn't change the structure of the data. We've seen it in detail in the mental models course. So what I can do here is to use a window function to get the maximum value over the sum of slots. And then I will say over to make it clear that this is a window function, but I won't put anything in the window definition because I just want to look at my whole data set here. And I can label these max slots. And if I look at the data here, you can see that I will get the maximum for every row. And then to get the correct result, I can add a simple filter here saying that total slots should be equal to max slots. And I will only want to return facility ID and total slots. So this also solves the problem. What's interesting to note here, for the sake of understanding window functions more deeply, is that the aggregation function for this window clause works over an aggregation as well. So here we sum the total slots over each facility, and then the window function gets the maximum of all of those value. And this is quite a powerful feature. And if I look at my map over here, I can see that it makes perfect sense, because here is where we group by facility ID, and here is where we compute the aggregation. And then the window comes later, so the window is aware of the aggregation, and the window can work on that. So a few different solutions here, and overall a really interesting exercise. List the total slots booked per facility per month, part 2. So this is a bit of a complex query, but the easiest way to get it is to look at the expected results. So what we see here is a facility ID, and then within each month of the year 2012, we get the total number of slots. And at the end of it, we have a null value here, and for facility 0, and what we get is the sum of all slots booked in 2012. And then the same pattern repeats with every facility. We have the total within each month, and then finally we have the total for that facility in the year. So there's 2 levels of aggregations here, and then if I go at the end, there's a 3rd level of aggregation, which is the total for all facilities within that year. So there are 3 levels of aggregation here. By increasing granularity, it's total over the year, then total by facility over the year, and then finally total by facility by month within that year. So this is a bit breaking the mold of what SQL usually does, in the sense that SQL is not designed to return a single result with multiple levels of aggregation, so we will need to be a bit creative around that. But let us start now with the lowest level of granularity. Let's get this part right, facility ID and month, and then we'll build on top of that. So the table that I need is in the bookings table. And first question, do I need to filter this table? Yes, because I'm only interested in the year 2012. So we have seen that we can use the extract function to get the year out of a timestamp, which would be start time. And we can use this function in a where filter. And what this function will do is that it will go to that timestamp, and then we'll get an integer out of it. It will get a number. And then we can check that this is the year that we're interested in. And let's do a quick sanity check to make sure this worked. So I will get some bookings here, and they will all be in the year 2012. Next, I need to define my grouping, right? So I will need to group by facility ID, but then I will also need to group by month. However, I don't actually have a column named month in this table, so I need to calculate it. I can calculate it once again with the extract function, so I can say extract month from start time, and once again this will go to the start time and spit out a integer, which for this first row would be 7. And as you know, in the group by, I can select a column, but I can also select an operation over a column, which works just as well. Now after grouping, I cannot do select star anymore, but I want to see the columns that I have grouped by. And so let us do a quick sanity check on that. It looks pretty good. I get the facility ID and the month, and I can actually label this month. And next, I simply need to take the sum over the slots within each facility and within each month. And when I look at this, I have my first level of granularity, and you can see that the first row corresponds to the expected result. Now I need to add the next level of granularity, which is the total within each facility. So can you think of how can I add that next level of granularity to my results? The key insight is to look at this expected results table and to see it as multiple tables stacked on top of each other. One table is the one that we have here, and this is total by facility month. A second table that we will need is the total by facility, and then the third table that we will need is the overall total, which you could see here at the bottom. And how can we stack multiple tables on top of each other? With a union statement, right? Union will stack all the rows from my tables on top of each other. So now let us compute the table which has the total by facility, and I will actually copy paste what I have here, and I just need to remove a level of grouping, right? So if I do this, I will not group by month anymore, and I will not group by month anymore. And once I do this, I get an error. Union query must have the same number of columns. So do you understand this error here? So I will write a bit to show you what's happening. So how does it work when we union two tables? Let's say the first table in our case is facility ID, month, and then slots. And then the second table, if you look here, it's facility ID and then slots. Now when you union these two tables, SQL assumes that you have the same number of columns and that the ordering is also identical. So here we are failing because the first table has 3 columns and the second table has only 2. And not only we are failing because there's a numbers mismatch, but we are also mixing the values of month and slots. Now this might work because they're both integers, so SQL won't necessarily complain about this, but it is logically wrong. So what we need to do is to make sure that when we're unioning these two tables, we have the same number of columns and the same ordering as well. But how can we do this given that the second table does indeed have 1 column less, it does have less information. So what I can do is to put null over here. So what happens if I do select null? This will create a column of constant value, which is a column of all nulls. And then the structure will become like this. Now when I union, first of all, I'm going to have the same number of columns, so I'm not going to see this error again that we have here. And second, in the facility ID is going to be mixed with the facility ID, slots is going to be mixed with slots, which is all good. And then month is going to be mixed with null, which is what we want, because in some cases we will have the actual month, and in some cases we won't have anything. So I have added null over here, and I am unioning the tables. And if I run the query, I can see that I don't get any error anymore, and this is what I want. So I can tell that this row is coming from the second table because it has null in the value of month, and so it's showing the total slots for facility 0 in every month, whereas this row came from the upper table because it's showing the sum of slots for a facility within a certain month. So this achieves the desired result. Next, we want to compute the last level of granularity, which is the total. So once again, I will select my query over here, and I don't even need to group by anymore, right? Because it's the total number of slots over the whole year. So I can simply say sum of slots as slots and remove the grouping. Next, I can add the union as well so that I can keep stacking these tables. And if I run this, I get the same error as before. So going back to our little text over here, we are now adding a third table, and this table only has slots. And of course, I cannot, this doesn't work because there's a mismatch in the number of columns. And so the solution here is to also add a null column here and a null column here. And so I have the same number of columns, and slots gets combined with slots, and everything else gets filled with null values. And I can do it here, making sure that the ordering is correct. So I will select null, null, and then sum of slots. And if I run this query, I can see that the result works. The final step is to add ordering sorted by ID and month. So at the end of all of these unions, I can say order by facility ID month. And I finally get my result. So this is now the combination of 3 different tables stacked on top of each other that show different levels of granularity. And as you can see here in the schema, we added null columns to 2 of these tables just to make sure that they have the same number of columns and that they can stack up correctly. And now if we look again at the whole query, we can see that there are actually 3 select statements in this query, meaning 3 tables, which are calculated and then finally stacked with union. And all of them, they do some pretty straightforward aggregation. The first one aggregates by facility ID and month after extracting the month. The second one simply aggregates by facility ID. And the third one gets the sum of slots over the whole data without any grouping. And then we are adding the null constant columns here to make the column count match. And it's also worth it to see this in our map of the SQL operations. So here you can see that this order is actually repeating for every table. So for each of our 3 tables, we are getting our data, and then we are running a filter to keep the year 2012. And then we do a grouping and compute an aggregation and select the columns that we need, adding null columns when necessary. And then it repeats all over, right? So for the second table, again, the same process. For the third table, the same process, except that in the third table, we don't group by. And then when all 3 tables are done, the union runs. The union runs and stacks them all up together. And now instead of 3 tables, I only have 1 table. And after the union has run, now I can finally order my table and return the result. List the total hours booked per named facility. So we want to get the facility ID and the facility name and the total hours that they've been booked, keeping in mind that what we have here are number of slots for each booking, and a slot represents 30 minutes of booking. Now to get my data, I will need both the bookings table and the facilities table, because I need both the information on the bookings and the facility name. So I will get the bookings table and the facilities table. And join them together. Next, I don't really need to filter on anything, but I need to group by facility. So I will group by facility ID, and then I also need to group by facility name, otherwise I won't be able to use this in the select part. And now I can select these 2 columns. And to get the total hours, I will need to get the sum of the slots, so I can get the total number of slots within each facility. And I will need to divide this by 2, right? So let's see what that looks like. Now, superficially this looks correct, but there's actually a pitfall in here. And to realize the pitfall, I will take some slots as well before dividing it by 2. And you can see it already in the first row. 911 divided by 2 is not quite 455. So what is happening here? The thing is that in Postgres, when you take an integer number, such as some slots, the sum of the slots is an integer number, and you divide by another integer, Postgres assumes that you are doing integer division. And since you are dividing two integers, it returns an integer as well. So that means that, that the solution is not exact if you are thinking in floating point numbers. And the solution for this is that at least one of the two numbers needs to be a floating point number. And so we can turn 2 into 2.0. And if I run this, I now get the correct result. So it's important to be careful with integer division in Postgres. It is a potential pitfall. Now, what I need to do is to reduce the number of zeros after the comma. So I need some sort of rounding. And for this, I can use the round function, which looks like this. And this is a typical function in SQL. And how it works is that it takes two arguments. The first argument is a column. And actually, this is the column, right? This whole operation. And then the second argument is how many figures do you want to see after the zero? After the comma, sorry. So now I can clean this up a bit. Label this as total hours. And then I will need to order by facility ID. And I get my result. So nothing crazy in here really. We source our data from a join, which is this part over here. And then we group by two columns. We select those columns and then we sum over the slots, divide, making sure to not have integer division. So we use one of the numbers becomes a floating point number, and we round the result of this column. List each member's first booking after September 1st, 2012. So in order to get our data, where does our data live? We need the data about the member, and we also need data about their bookings. So the data is actually in the members and bookings table. So I will quickly join on these tables. And we now have our data. Do we need a filter on our data? Yes, because we only want to look after September 1st, 2012. So we can say where start time is bigger than, and it should be enough to just provide the date like this. Now in the result, we need the member's surname and first name and their memory ID. And then we need to see the first booking in our data, meaning the earliest time. So again, we have an aggregation here. So in order to implement this aggregation, I need to group by all of these columns that I want to call. So surname, first name, and member ID. Now that I have grouped by these columns, I can select them. So now I have grouped by each member, and now I have all the dates for all their bookings after September 1st, 2012. And now how can I look at all these dates and get the earliest date? What type of aggregation do I need to use? I can use the mean aggregation, which will look at all of the dates and then compress them to a single date, which is the smallest date. And I can call this start time. Finally, I need to order by member ID. And I get the result that I needed. So this is actually quite straightforward. I get my data by joining two tables. I make sure I only have the data that I need by filtering on the time period. And then I group by all the information that I want to see for each member. And then within each member, I use mean to get the smallest date, meaning the earliest date.